Hello friends. Now in this video, we are going to deal with the example question 3.6, motion in a straight line. Okay, so let me read the question for you. Example 3.6, Galileo's law of odd numbers. Galileo's law of odd numbers. The distances traversed during equal intervals of time by a body falling from rest stand to one another in the same ratio as the odd numbers beginning with unity. Beginning with unity. In the bracket it is given the 1 is to, 3 is to, 5 is to, 7 is to, etc. So we have to prove this one. So what is the meaning of this question? Just an example. An object is now releasing. Okay, an object is now releasing from rest. So as you already know, the object will come down here. Now what is asking for? We have to prove that while an object is coming from rest, that is called free fall, right? In each interval of time, it is traveling in distance, right? It is vertical displacement is there. So we have to prove that in each interval of time, the distances traveled are in the ratio 1 is to, 3 is to, 5 is to, 7 is to, etc. That means the ratios are coming in terms of what? Odd numbers. This is called what? Galileo's law of odd numbers. Galileo's law of odd numbers. So now let's prove this one. An object is falling freely. An object is falling freely. So this is the case. An object is falling freely. We have just now discussed here. Y is equal to minus half gt square. The formula become what? Minus half gt square. Now we have to calculate what is the distances traversed during each interval of time. So let's discuss here. The time interval we are taken as starting time interval 0. Next one, say it as the next time interval is set as tau. Okay, we can write t1, t2, t3, etc. So I'm writing here tau. Another time interval is here what? 2 tau, 3 tau, 4 tau, etc. So these are the equal time interval starting with 0, 0, tau, 2 tau, 3 tau, 4 tau, etc. Okay. So now you can write this as when time. So first one you are writing here time. When time is equal to 0, when time t is equal to 0, what is the vertical displacement y? Vertical displacement y formula, y is equal to minus half gt square. If you substitute for t is equal to 0, what is the y become? 0. Y become 0. When time t is equal to tau, when time t is equal to tau, we can write here substitute for the t. So the equation for the y become what? Minus half into g tau square. G tau square. Now next time interval, what is the next time interval here? 2 tau. So I can write here the time interval is when it is 2 tau. The equation become what? Minus half into g into, now instead of tau, what do we have to substitute here? 2 tau. So 2 tau square. 2 tau square means what? 4 tau square. So I can write here tau square into 4. Now next one, when the time interval become now 3 tau, what is the equation become? Minus half into g into, instead of t we have to substitute for 3 tau square. So what is the 3 tau whole square? 9 tau square. So I can write here minus half into g into tau square into, what is next one is coming? 3 into 3, 9. So 9 tau square. So I have written like this 4, 9. One more you can write down here. When it is 4 tau, the equation become minus half g tau square into 16. Into 16. Now let's write in terms of y0. I am writing here y in terms of y0. I am going to write here in terms of y0. Say it as y0 is equal to minus half into g tau square. Alright. So what is this equation become? In terms of y0, this is equal to 0 itself. Now minus half g tau square we have considered as y0 in terms of displacement. So I can write it as y0. If it is y0, this can be written as what? 4y0. This can be written as what? 9y0, and the last one can be written as what? 16y0. Okay, 0, half minus half gt square is considered as y0. So y0, this become 4 into y0, 9 into y0, 16 into y0. Now what is the distance traversed in each interval of time? So what is the distance traversed in each interval of time? So let's see here, the next column we can write here, the distance traversed. What is that? The distance traversed. So time starting with the 0. So in between 0 and 2, what is the distance traversed here? y0 minus 0, that is equal to y0 itself. Next one, in between tau and 2 tau, what is the distance traversed? 4y0 minus y0, that is equal to 3y0. What is the distance traversed in between 2 tau and 3 tau in that time interval? We can write here 9y0 minus 4y0, that is equal to 5y0. And one more here, the time interval 3 tau and 4 tau, in between how much distance it is traversed? 16 minus 9, that is equal to 7y0, and it will continue like this. Now if you are writing the ratio, we can write it as y0 is to 3y0 is to 5y0 is to 7y0 is to etc. That is equal to what? 1 is to 3 is to 5 is to 7 is to etc. So we have now proved here the distance traversed in equal interval of time. It is in the ratio of 1 is to 3 is to 5 is to 7, and it is proved by Galileo, and that's why it is called what? Galileo's law of odd numbers. Okay, so I hope it is clear. Just do this problem here. Thank you all of you.